let's solve trig equations where there's going to be multiple answers. The examples I'm going to show you today, I'll have a theta over 2 as well as a 2 theta, but there could be an example that you have to solve maybe where there's 4 theta or something like that. So we're going to have multiple answers. I'm going to walk you through the steps. It's going to be great. All right, let's do it. So in our first example here, we want to get the trig by itself. So you're just going to do general solving techniques. I like to call it like SADMAP, which sounds really weird, but it's essentially like reverse PEMDAS. We want to isolate the trig. That's our first phase here. So the inverse of multiplication is division. Okay, nice. Also, I don't really like the theta over 2. So I'll substitute in place of theta over 2. I'll just pretend that it's theta for now, but I'm going to switch it back later. You could put an x in place of theta over 2. Whatever you do, just be careful. Okay, so it looks a little bit less of an eyesore now if it reads 2 secant theta. Okay, now recall, secant is 1 over cos, and 2 is 2 over 1. Now, there's a couple ways to handle this. I think the most clear way that's going to reach the most amount of viewers is if you have two fractions, two ratios that are equal to each other. If you have a proportion, you just cross multiply. So you'll get 1 multiplying bottom left, top right diagonals equals 2 cos theta. Again, our goal with all of this initial solving is to get the trig by itself. Oh, look, 1/2 equals cosine theta. You're used to seeing things like that. This looks a lot more tame than the original problem. So that's pretty sweet. Just don't forget that this theta really, we're going to turn it into a theta over 2 in a moment. Okay, so you ask yourself, maybe you have a unit circle table in front of you, or you have these memorized, hopefully one or the other. You ask yourself, well, where is cosine equal to 1/2? And again, I'm still solving for theta, and I'll slingshot it back. I'll turn it into theta over 2 in a moment. And by the way, in this video, I'm going to give my answer in degrees and radians just to reach as many people as possible, depending on what you're most comfortable with and or what is the requirement of your teacher. Apparently, I'm in low power mode. All right, let's keep going. So, where does this happen? Well, where is theta equal to 1/2? Where is cosine theta equal to 1/2? That's when theta equals 60 degrees, or in radian land, pi is like 180 degrees, so pi over 3. So that's our initial answer. But also, if you kind of wind around the unit circle, if you're chilling at some spot, let's say at 60 degrees, and you wind around again another 360, you'll be back in the same spot. So we have to account for those multiples. And we'll do that more in a moment. But there's another theta first before we account for the multiples. So maybe I'll call that theta 1. I'll call this theta 2. A little mnemonic, all students take calculus. We know everything's positive in the first quadrant, so there I have a 60-degree angle, or a pi over 3 angle. Well, cosine is also positive in the fourth quadrant, so I could have a 60-degree reference angle in the fourth quadrant as well. So that would be 300 degrees for my degree people, or in radian land, you could think of that as a full rotation of 2 pi less pi over 3, less 60 degrees. So kind of winding all the way around and then back a little bit. And if we get a common denominator, we have 6 pi over 3. 6 divided by 3 is the artist formerly known as 2 pi. Take away a pi over 3. We have that this is also 5 pi's over 3. By the way, I have videos on fractions. if you need some help with that. Okay, so again, these are sort of our answers, but we're not done. Our answers have theta, not theta over 2. And then we have to account for multiples of 360. In radian land, that's multiples of 2 pi. And we're just saying k is some integer. Similarly, we have 300, otherwise known as negative pi over 3. Either would be acceptable, plus multiples of 360. Or we could say 5 pi over 3 plus multiples of 2 pi, where k is an integer. So k could be -1 or 4 or 2 or 0. Okay? Now we have to kind of slingshot it back. We have to be careful and say, well, we're really dealing with a theta over 2 here. So we're going to have to clean up our answers. And again, notice I'm doing it in degrees and in radians. Let's just key in on degrees first. Okay, so really, we have to replace theta by theta over 2. So what we need to do, and this is going to feel a little bit awkward, is we have to change or shape our original thetas. We solved for theta. We really needed to solve for theta over 2. So if we set our answer, let's just look at one of them. If we set that equal to theta over 2, what we're really going to need to do is we're going to need to do the inverse of division, which is multiplication to each side. Okay, so this is going to look a little bit weird here, but let's just roll with it. Now our final answers for theta, we saw division, so we did multiplication. Again, that's the inverse. We now have an answer of 120 plus 720k, where k is in the integers. Okay? Similarly, our other answer, if we did the same thing and we multiplied both sides by 2, we would have 600. I'm taking this theta 2 answer. I'll multiply the 300 by 2, and then I'll also have my multiples of 720k. Now I'm going to hack this down. 600, that's winding around the axis multiple times. Let's hack that down by 360. That'll be 240 plus 720k. Now, again, depending on your teacher, this might be acceptable. Here's one of your answers. Here's another one of your answers, where k is an integer. However, your teacher might want to limit you. They might say, hey, really, you should have theta between 0 and 2 pi, or really in this context, since I'm in degree land, between 0 and 360 degrees. So we should really clean these up and make sure our answers fall between 0 and 360 degrees. We have two of the answers. We have 120, as well as we have 240. All right? They both fall within 360 degrees. Now, if I added this multiple 720, that's going to actually have me wrap around twice, but I'm going to fall in the same spot. Okay? Similarly, 240, since I have that wraparound of 720k, that's two 360s, I would be in the exact same spot. So actually, believe it or not, these are my two solutions. There are not any others. And so if you wanted to, we could have played the same game in Radians land. We could have taken Remember, we had theta over 2, so we would multiply both sides by 2. We can multiply these answers by 2 in radians land as well, and so we'd have 2 pi over 3 and 10 pi over 3. 2 pi over 3 as well as theta could be 10 pi over 3. Oh, but we've got to hack that down. If we had the restriction, instead of degrees, radians, we'd have to be between 0 and 2 pi. Perhaps non-inclusive. That would make the most sense. We could hack down 10 pi over 3 by 2 pi, which is 6 pi over 3. Just kind of wind around backwards a little bit. That would be 4 pi over 3. So those would be our 2 radians answers that fall within the given parameters. So you really need to know your teacher. You need to know the expectations that your teacher has. And that's how you're going to present your answer most carefully. But so be careful. If you see a 3 theta in your answer, or a theta over 2, or a 4 theta, you have to solve things carefully. If you want, you can replace theta with theta over 2, but you have to remember to slingshot it or bring it back. That is super duper important. All right, so here, instead of a theta over 2, now we have a 2 theta. Well, we can handle this. We could say, oh, I don't like 2 theta. Let's just replace 2 theta with theta. I want this problem to be positive just for fun. Okay? So the problem reads tan of 2 theta equals root 3 over 3. I'll first do a little replacement. I don't like 2 thetas. Let's just think of it in terms of theta. This problem, we can ask ourselves, well, where is tan theta equal to root 3 over 3? Recall that happens at 30 degrees. Now, if you think of the mnemonic, all students take calculus, where else is tan positive? Well, we could have tan be positive in the 3rd quadrant with a 30-degree reference angle. So that would be like going a full 180 plus the 30-degree reference angle. That's 210 degrees. Okay? And then we'll have multiples of 360, where k is an integer. Now, again, I'm going to do this in degrees first. You can fast forward if you want radians. But the process is going to be very similar. So even if you want radians, you can stay with me. Here's theta 1, there's theta 2. Keep in mind, we have to slingshot it back. Instead of theta, we want our answers to be a 2 theta. So if we were to replace our theta, we have to slingshot it back. What if it was really a 2 theta? And we want to solve for theta. The inverse of multiplication is division. We're going to have to divide our answers, every single piece or part, by 2. So really, theta 1 is 15 degrees plus a little 180-degree multiple, or 210, take half of that, that's 105, plus 180-degree multiples. Now what's interesting, because this theta is larger than 1, we're actually going to expect more than 2 answers here. Since theta is 2, that's 1 more than theta, we're going to incur a couple more answers, 2 more to be specific. If this were a 4 theta, we would initially have 2 answers, and then we would get 6 more. 4 theta minus 1 is 3. 3 times 2 is 6, because we have the double answers, and then we sort of divide up 360. In this case, we divided it in half, so we incurred a couple more answers. But if you divide it into 4, you're going to have 3 more answers that are going to fit in that 0 to 360 degree band. Maybe I'll make another video with a 4 theta just for funsies. Okay, so if your teacher wants you to go between 0 and 360 and explicitly state them all, well, your answers are 15, 105. 105 plus 180, that falls in the 0 to 360 degree region. So that's 295 degrees. And 15 and 180, that's 195 degrees. Now we have all 4 answers. Another way you can think about it is if that B value or K value, depending on who taught you this, if that number in front of theta is a 2, you can expect, first of all, tangent is positive in 2 quadrants, but then we're multiplying it by 2. There are our 4 answers here. Now, we could do this in radians as well. Initially, our theta 1 and our theta 2 would be pi over 6 and 7 pi over 6 plus our 2k pi's. But then we really had to place a 2 theta there. We substituted that in, but then we have to again solve for just good old-fashioned theta, so we have to divide everything by 2. That's like putting a 2 in the denominator. So our theta 1 is really a pi over 12 plus pi, aka 180 degree multiples, and we also have a 7 pi over 12. Dividing by 2, multiplied by 2 in the denominator. We also have our k pi multiples again, where k is an integer, 0, -1, 5, 4. That's the general way to say it, but if you need to wedge your theta between 0 and 2 pi, well, you have multiples of pi here. You can fit a couple more answers. So again, our final answer in radian land would be, we have pi over 12, we have 7 pi over 12. But then when we add pi, that's like adding 12 pi over 12 to our top answer. 12 pi over 12 plus pi over 12, that's 13 pi over 12. 7 pi over 12 plus 12 pi over 12, that's 19 pi over 12. And those are the 4 answers in radians. I hope that this has been helpful for you. And just to do a little recap of everything we did essentially SADMAP first to isolate the trig equation. Okay? In addition, we replaced the ugly theta, the theta expression, the theta over 2 or the 2 theta or the 4 theta, we replaced it with just good old-fashioned theta at first, just so it didn't look so ugly. We considered the signs of our answer to think about which quadrants we were in, and we used reference angles. So we came up with 2 solutions. But then we had to bring it back. We had to replace, apparently I still need to charge, we need to replace theta with whatever we substituted in place of it, theta over 2, or 4 theta, or 2 theta. We need to replace the theta with the original that we substituted, okay? And then we need to consider, this really gets a star, we need to consider 2 pi over k multiples. Okay, so that was really something that we needed to be careful with. So when there was a 4 theta, and you could also think of that as 360 degree over k. If we had a 4 theta, you'd have 2 pi over 4. You'd have to think about pi over 2 multiples. Or in those of you in degree land, you'd have to add in multiples of 90 to be within the threshold of 0 to 360 degrees. But you need to make sure you have all of the solutions. It's something to be very careful of and to Just get your muscle memory up. Like, redo these problems 5 times. That's how you're going to get as strong as possible. Have a trigonometric day. Thank you so much.